Today we are solving rational equations and inequalities. In order to solve a rational equation, first you want to identify the least common denominator. To do that, you will factor each denominator. The least common denominator will contain each factor the most times it occurs. Then we will multiply both sides of the equation by the least common denominator, which will eliminate our fractions. Then we'll solve the resulting equation, distribute, combine like terms, get the variable to one side, add or subtract, multiply or divide. So to factor our denominators, 12 is 2 times 2 times 3. X minus 4 cannot be factored. And then for 48, we have 2 times 2 times 2 times 3. So our least common denominator will contain each factor the most times it occurs. So we need 2 as a factor 4 times, 3 one time, and x minus 4 one time. And then we multiply both sides by the least common denominator, and we cancel out our like factors, or divide out like factors. Then we will multiply the resulting equation. So 7 times 2 times 2 gives us 28, and then 9 times the 2 times 2 times 2 times 3 gives us 48, and then we'll have 55 times x minus 4. So then we'll distribute the 28 and multiply 9 times 48. Then we combine like terms on the left-hand side here, negative 112 plus 432. And then we want to get the variable to one side, so subtract 28x from both sides. And then to isolate x, we would add 220 to both sides, and then divide by 27. And our answer is x equals 20. So for number 2, looking at our denominators, m minus 4 cannot be factored, but we've got 3m squared minus 18m plus 24. So I'm going to make a side note here for factoring that. First, we factor out the greatest common factor of 3. Then factoring m squared minus 6m plus 8. Think about what multiplies to 8 and adds to 6. Or negative 6, so that would be negative 2 and negative 4. And then this third denominator, we can factor a 3 out of that, so that becomes 3 times m minus 2. So now that we have factored our denominators, we can identify the least common denominator. It contains each factor the most times it occurs, so 3 times m minus 2 times m minus 4. And then we are going to multiply both sides by the least common denominator, and then we will divide out like factors, and then we'll solve the resulting equation. So I multiplied 2m times 3 to get 6m, and then here I just distributed the minus to the m squared plus 7m plus 4, and then over here I distributed the 4m. Next we will distribute 6m to the m minus 2. Then we combine like terms, so 6m squared minus m squared gives us 5m squared. And then I also combine negative 12m minus 7m to give us negative 19m. And then we would subtract 4m squared from both sides and add 16m. Since we have a quadratic equation, we want to get it in standard form, which is equal to 0. And then our resulting quadratic trinomial is factorable because there are numbers that multiply to negative 4 and add to negative 3. So that would factor into m minus 4, m plus 1. And the zero product property tells us if two things multiply together to equal 0, one of them must be 0. So then we set each factor equal to 0, and then we'll solve those resulting equations. So we get m equals 4 or m equals negative 1. 4 is extraneous because it is a 0 of the denominator. So look up here, 4 minus 4 would be 0. So we would have like 8 divided by 0, which is undefined. So you also want to think about after you've factored your denominators, anything that would make it your denominator 0 cannot be a solution. And number 3, we have a mixture problem. So we've got rubbing alcohol, a commonly used first aid antiseptic, typically contains 70% isopropyl alcohol. Suppose you're adding a 50% isopropyl alcohol liquid to 200 milliliters of a liquid that is 91% isopropyl alcohol. How much of the 50% isopropyl alcohol liquid should be added to create rubbing alcohol that is 70%? So with an equation like this, it's helpful to always start with a verbal model. So the percentage of isopropyl alcohol in the liquid would be the amount that is just isopropyl alcohol divided by the entire amount of liquid. So if we're starting with 91% of 200 milliliters, and we're going to add an unknown amount of 50%, it would look like this. So we've got 91% of 200, that's how much of it is isopropyl alcohol, plus we're adding a 50% mixture times an unknown amount of that mixture. The total, we started with 200 milliliters of liquid and then we're adding an unknown amount. We want to make that equal to 70 over 100, 70%. The word percent means per 100, so 70 over 100. Since this is a proportion, we will set cross products equal to each other and solve. So simplifying this, we will distribute the 70 and then distribute the 100. And then we want to get the variable to one side, so I'm going to subtract 50x from both sides, and I'm subtracting 14,000 from both sides. So we get 20x equals 4,200, divide by 20, and we get x equals 210. So x represents the milliliters we should add to the 91% solution to bring it down to 70%. So 210 milliliters of 50% isopropyl alcohol liquid should be added. Next, we're going to do some speed problems where when you're going with the wind versus when you're going against the wind. And I always use the analogy of the moving sidewalks at an airport. If you're walking with the direction of the sidewalk, your speed that you're going will be your walking speed plus the speed of that sidewalk. If you were to walk in the opposite direction, now the speed that you're going will be the speed that you're walking minus the speed of that conveyor belt. So the wind acts as like this conveyor belt. So it's either when you're flying with the wind, it adds to your speed. When you're flying against the wind, it subtracts from your speed. Example 4. Mexican free-tailed bats have an average flight speed of 25 miles per hour. Suppose it takes one of the bats 5 hours to fly 121.8 miles round trip one night. Assuming the bat flew at a constant speed, determine the speed of the wind. So the rate with the wind is going to be the 25 plus wind speed. The rate against the wind would be your 25 minus your wind speed. And since the round trip is 121.8 miles, we want to divide that by 2 to figure out the distance for one way. So one way is 60.9, and distance equals rate times time. Your time is distance divided by rate. So we're given the total time. So we want to think about the time that they flew with the wind and then the time they flew against the wind. That equals our total time. So they went 60.9 miles with the wind, so their rate would be 25 plus wind speed, plus 60.9 miles against the wind, so 25 minus the wind equals their total time of 5. So then we would multiply both sides by the least common denominator, which would be both denominators multiplied together, 25 plus W, 25 minus W, and then we'll cancel out like factors, and then we'll simplify the resulting equation. So I distributed the 60.9 for this part, distributed the 60.9 here, and then I FOILed the 25 plus W, 25 minus W. We're going to distribute the 5 here and combine like terms on the left-hand side. And then subtract 3,125 from both sides, divide by -5, and then take the square root of both sides. Since it wouldn't make sense for the wind speed to be a -4, our answer is that the wind speed is +4 miles per hour. And then we have a work problem. So if it takes a 24-row planter 10 hours to plant a field, and 6 hours if a 16-row planter is also used, how long would it take if only the 16-row planter were used? So rate times time equals work. And so if we wanted to solve that for rate, since that's what we're talking in terms of in this word problem, rate equals your work divided by time. The work being accomplished in this scenario is one field, so we'll use 1. The 24 planter rate plus the 16 planter rate equals their rate together. So we're going to use P, the unknown, to represent how long it would take 16-row planters time to do it on its own. So the 24-row planter, one field in 10 hours plus one field in unknown amount of hours equals one field in 6 hours. So to solve this for P, we multiply both sides by the least common denominator, which would be 30P. And then that gets rid of our denominators. So 30 divided by 10 gives us 3P. 30 divided by P is 30. And then 30P times 1/6 is 5P. So then we would subtract 3P from both sides, divide by 2. And then that tells us that it would take the 16-row planter 15 hours to plant the field alone. To solve rational inequalities, first we want to figure out the excluded values, so anything that would make your denominator 0. Then we'll solve the related equation and use the values to determine previous steps to divide a number line into intervals, and then we test a value in each interval to see if it makes the inequality true. So excluded values, -1 would be our only excluded value because -1 plus 1 is 0, so that's what would make the denominator 0. So that will be one of our points where we divide up our number line. Next, we're going to solve the equation. So we got to multiply both sides by the least common denominator, which contains each factor the most times it occurs. So we'll cancel out like factors. And then I distributed the 3x here, or multiplied together 5 times 2 times 3. Now on the right-hand side, we will FOIL, then subtract 2x squared from both sides, add 6x, add 8, because we want to get this equation in standard form. Then what multiplies to -22 and adds to 9? That would be +11 and -2, and then set each factor equal to 0. So we get two solutions, -11 and 2. So we have to write a number line and then divide it up with our solutions, -11, +2, and then also our excluded value from the beginning, which is at -1. So we have 1, 2, 3, 4 different sections on this number line. So I'm going to test the point -13, so by plugging that back into the original equation, and you could do that in a calculator, determine whether or not you got a true statement. And that was determined to be false. Now we'll test a point between -11 and -1, and I chose -4. So substituting -4 in for x gave us a true statement. Okay, and then choosing something in between this interval, -1 and 2, I use 0. When we substitute in 0, we get a false statement. And then testing something on this last interval, I used 3. If I substitute in 3, I get a true statement. So then our answer is this interval between -11 and -1, and then also this interval here, everything greater than 2. And here's how we would write that in interval notation. Number 7, Jamila runs an online store that sells custom hats. She spends $378 on an embroidery machine. In addition, it costs Jamila $1.85 to make each hat. How many hats will Jamila have to make so that the average cost per hat is less than or equal to $5? So her total cost divided by number of hats will equal her average cost. She has the machine, $378 plus $1.85 per hat. Divide that by the number of hats, and we want that to be less than or equal to x. So I'm going to multiply both sides by x, and then we have a variable on both sides, so subtract 1.85x from both sides, and then divide by 3.15x. So the number of hats is greater than or equal to 120, so she must make at least 120 hats for the average cost to be $5. And that's because her embroidery machine was so expensive. So the more hats she makes, the more that number gets divided up and becomes smaller. Thank you for watching.